In this session, we'll be talking about radon, which is a hazard that you may not be aware of, but in fact is all around us all the time and actually has some quite profound health effects that we need to be concerned about. So let's begin by asking the question, what is radon? Well, radon is a naturally occurring radioactive gas. It's colorless, it's odorless, and it's tasteless. In other words, you cannot know that it's there. There's no way for us to perceive whether or not radon's there or in what concentrations. It's the heaviest gas in nature, which we'll talk about later actually has some ramifications for how our exposure happens. Radon comes from radioactive decay of uranium, which is actually present all over the world in soil, in rock, and dissolved in groundwater. Now, the problem with radon is that it emits ionizing radiation as it decays into several radioactive isotopes. These are commonly known as radon decay products, or even more commonly, radon daughters. So in fact, the radon itself is not necessarily what causes health effects. It's the decay products. It's what radon turns into as it decays and emits radiation. So in the United States, we're relatively fortunate that the Environmental Protection Agency, EPA, has done surveys at the county level to determine how much radon is around us. That's the good news. The bad news is there is a lot of radon around us. So as you can see from this map, in red, we're looking at radon zones that have essentially the highest potential for radon exposure. In orange, we're looking at zones that have sort of a moderate potential for radon. And in yellow, we're looking at zones that have low potential for radon. So I think looking at this map here, you can have a couple of kind of gross observations. One of them is that there are parts of the United States, for example, the Northwest and the South, where there is not a huge potential for radon exposure. The other worse conclusion you can draw from this map is that there are enormous swaths of the United States that have the highest potential for radon. So that's the bad news. And in fact, when we consider Michigan, where the University of Michigan is, the news is perhaps more mixed. So if we look at a map of Michigan, you can see Washtenaw County, where the University of Michigan is located, is actually Zone 1. So we have the very highest potential for radon exposure here, as opposed to the middle part of the state, which has lower exposure potential, and the eastern part of the Upper Peninsula. So the bottom line from these two maps is that radon is everywhere. How much of it is available to enter the air is due to a range of factors, including soil composition and geology. And in fact, across the U.S., about 1 in 15 homes are in Zone 1 and have the highest potential for radon exposure. So you may ask the question, well, how do we figure out how much radon we're exposed to? And it turns out radon is really the one type of radiation that we can easily measure. There are test kits available to do several different types of tests. Now, I mentioned again that radon is the heaviest gas in nature. Because this is a heavy gas, it tends to accumulate at our homes in the lowest level. It doesn't rise like other lighter than air gases do. And there's actually two types of tests we can conduct to figure out how much radon we're getting when we're at home. One of them is a short-term test that lasts a very short period, between 2 days at the minimum up to 90 days maximum. This is essentially a screening test, so it's a quick test to figure out what is our exposure potential. And there's a couple different devices we can use for this. One of them is basically a charcoal, activated charcoal substance that you place in the lowest lived-in level of your home and then send into a laboratory for analysis. And another one is a real-time instrument that actually has essentially a 2-day moving average that'll report to you that you can compare to health standards, which we'll talk about in a moment. The other type of test we have is a long-term test. So this one could last from 3 months all the way up to an entire year. It turns out radon levels fluctuate quite a bit across seasons, so this long-term test gives you a more accurate sense of what your long-term average exposure level is in your house. So what does radon do to us? Why should we be afraid? Well, actually not afraid, but what do we need to worry about? It turns out that radon decay products readily deposit in your lungs. So you breathe them in and they deposit in the very sensitive tissues inside your lungs. They end up irradiating those cells in your airways. And through that radiation, radon causes cancer. So this is classified as a Class A carcinogen. Radon is known to cause cancer in humans. And in fact, this may surprise you, but radon is the second leading cause of lung cancer in the United States. I'll ask you to take a moment and ask yourself, what is the first or leading cause of lung cancer in the U.S.? And if you answered tobacco smoke, you're absolutely right. And if you did answer that, congratulations. That's one of our few public health successes where we've educated the public that tobacco smoke is bad for you. Hopefully now you'll get educated that radon isn't good for you either. And in fact, the U.S. Environmental Protection Agency estimates that of about 157,000 lung cancer deaths that happened in the U.S. in 1995, over 21,000 of them were due to radon. Now, the scary thing about radon is that exposure does not cause any warning symptoms. So basically, the first symptom you have is lung cancer. So this is why it's important for us to take preventive action. It also turns out that radon has more recently been linked to stomach cancer if you drink water that's contaminated with radon. So exactly how risky is radon exposure? This may be surprising again, but radon results in far more deaths than other events that we commonly view as risky. So again, I mentioned that at least in 1995, there were about 21,000 deaths per year from radon. How does that stack up? That's more deaths than we had from drunk driving. It's more deaths than we had from falls in the home. It's almost 7 times more than we had drownings, and much more than we had from home fires. So again, these other risky activities for the most part, pale in comparison to the risk associated with radon, something most of us probably don't think about on a daily basis. And it turns out as bad as radon is for us, if we're smokers, it's much, much worse. So smokers are about 9 times more likely to develop lung cancer from radon than non-smokers. And in fact, if we look at all the deaths of smokers from lung cancer, almost 25% of lung cancer deaths among smokers are actually due to radon. So what exposure standards are out there for radon now that we know that it does cause these potentially lethal health effects? Well, the big message here is that there is no known safe level of radon. So as with other sorts of radiation, we think any amount of exposure has some potential health effect. Now, back in 1991, the EPA surveyed home radon levels, again, in every county across the United States. And they measured about 1.3 picocuries per liter, so that's a unit for concentration of this sort of radiation. That was about the average level inside U.S. homes. So you might think, well, let me stay out of my house, I'll be safe. Well, in fact, there is radon everywhere, and outside U.S. homes, the concentration was about 0.4 picocuries per liter. So after that survey, the EPA said, we need to do something about this, and so we're going to set an action level of 4 picocuries per liter. This is, again, 10 times the outside concentration of U.S. homes. That's the level below which we'd like to have all U.S. homes be. Well, you might ask yourself, I can take a test and see what my radiation levels are from radon, but how does this stuff get into my house in the first place? And it turns out it's driven by air pressure differential. So when radon comes up from the ground, as it decays, it's basically drawn towards areas of low pressure. And your house, compared to the surrounding environment, is typically low pressure. And you often have a stack effect where warmer air on the lower levels tends to rise and pull the radon gas up with it, creating a vacuum again in the lower levels. So there's a number of different routes that radon can take to get into your home. It can actually come up through cracks in your foundation. It can also come up between cracks or points where different building materials meet. It can come in through cracks in your walls. It can actually just pass directly through building materials like wood. It can come up through water sources like your toilet. It can come in through open windows. And perhaps most surprisingly, it can come in through your water supply and then be aerosolized. So when you take a shower, for example, if your tap water is contaminated with radon, that radon is now in your home's air. So lots of ways that radon can get into our house. What can we do to prevent radon from accumulating in concentrations that are going to be worse for our health? Well, I'm happy to say there's actually a variety of alternatives available to us. So if you have an existing home, we can do something that's called sub-slab suction, and that's exactly what it sounds like. So basically, we punch a hole in the bottom of your basement floor, and we connect that hole to pipes In one of those pipes, we put a fan, and then we continue to run that pipe all the way up to the roof line of your house. And what this does is it creates a low pressure area right below your slab. The radon is drawn into that low pressure area, drawn up, and then basically ejected at the roof line of your house where you're presumably not going to be breathing it. This can be extremely effective. If you have a new home that's built in a high radon exposure zone based on those EPA maps we discussed earlier, that home has to include mitigation measures. And these mitigation measures, as pictured down here in the bottom right, include putting a tube where the radon can passively be drawn out of your house, again through what's called a stack effect. It also involves putting a layer of crushed gravel down beneath your slab, and then a layer of impermeable polyethylene that's designed to basically prevent that radon from coming up into your house through any other route than the radon pipe that goes straight up to your roof line. So how well do these things work? Well, in fact, they're incredibly effective, and they may reduce your levels by 99%. So this is the good news. Once we identify a radon problem, we can fix it. If you have radon in your tap water, there's two control options. One of them is basically filtration at the point of entry, so where the water enters your home. This can be very effective. Another option is to put something on each and every tap in your home, or point of use, as we say. That's not so effective. So in conclusion, radon is a very common exposure in some parts of the U.S. It is a known human carcinogen and is believed to cause a substantial fraction of lung cancer cases in the United States. And remember, as bad for us as it is, if we don't smoke, the risk is much, much higher among smokers. We do have a limit that's designed to protect our health, although this is not an enforceable limit. This is simply a recommendation from the Environmental Protection Agency. So if you test your house and your levels are above 4 picocuries per liter, that's when you need to consider doing some abatement, doing some changes to your home to reduce your exposures and make your home safer. And as I mentioned, there's a variety of mitigation techniques, and these can substantially reduce your exposures to radon when implemented properly. I've given you a few extra resources here to pursue. One of them is the State of Michigan Radon website, which is a superb resource, has lots of information. For those of us here at the University of Michigan, you may be interested in more local information from Washtenaw County. I've listed here a website that lets you know how you can obtain a radon test kit. These are very inexpensive. They cost between $10 and $15 and easy to use. And finally, I've posted a very good resource from the Environmental Protection Agency, a Citizen's Guide to Radon, which gives you some rules of thumb and more background information on what radon is, how it affects us, and what we can do about it. So with that, I will leave you to ponder whether or not, or more importantly, when you should test the radon levels in your house.